Okay, so for your CPT, as I mentioned before, I want you guys to be able to define some of your calculations, and then as a result be able to sort of crunch the numbers from scratch, as if you were doing it by hand. But of course, I don't want you to add up all the values by hand. There's 1,200 values for an entire, or more than 1,200 values for an entire 5-year span. So I'm going to show you how to use Excel effectively so you can get all these summations and you can do it all. So if you remember, there are a couple of videos that I have that I'll post if I haven't posted already on single variable stats and how to do those. This is a whole data set all the way down for 5 years. This is for BCE. But either way, to get single variable stats, I just have them listed here. It's very easy for you to do. And I need a mean for this. So let's say I was calculating my standard deviation. Okay. So for a mean, if you look at the formula, you need the summation of all your x values divided by the total amount of values. Now, one thing to keep in mind is my n value is 1,258. Okay, that's my sample size. Okay, and then when I go to do these calculations, I'm going to base it on that scenario. Okay, so first things first, what do you need to do? Well, if you're going to do it, from scratch, like you're doing this, for example, on a test or a quiz or something like that, you have to go for all the x values and you have to add them all up. So that, of course, you need a sum. So what I would have to do is I would have to go into this spot here, and this is where I want to add up all of my x values. This is single variable stats. My single variable is my stock price, or in this case, my closing price. And so I want to add up this entire column right here. Okay? To add up that entire column, I would have to use the sum function. Okay, of course, I'm not going to do it by hand. So if you remember how to do that, you can check out how to do those individually for single variable stats in those Excel videos that I have posted for you. But here I'm just going to go equals, and then I want to do sum. Okay? Sorry, I don't want to do equals. I want to go to fx, and then I want to go to sum function. Okay? Insert the function. Okay? And then it's going to anticipate what it is. Now, again, it's really important. If you notice, it goes from C3 all the way to C1260. That's my 1,258 values. Because you're going to use this a lot for sums, I would copy that. And then you can paste it in next time. That way you don't have to highlight the whole thing. Okay, it's actually a convenient way to do that. So anyway, so I can go ahead and do that sum, and it's 55,473 is the sum of the stock prices over 5 years. Okay, take you a long time to add that up. Now, for me to do my mean value, maybe I do my mean calculation over here. I would go equals, set up my own formula, and I would click on this value here. And then I would divide by my sample size, which is 1,258. Okay, maybe I'll make that a little, I don't know if I can make it bigger while I'm doing that. No, I can't. Okay, but then that's my mean value. Now, don't forget that we do have a function of calculating a mean that we can do as well. Let me get rid of that. And that function of calculating the mean using our fx application, I could go ahead and do it here. Now, they should agree with each other, okay? So if I go into this category for mean and I go fx and I look up, now remember the word for mean, of course, is average. So if you watch the other videos, I show you how to do that. And you pick your basic average and then you insert the function. Now, you're going to have to change this data series because it's going to make some assumptions for you. So again, that's why I copied and that's why I pasted it, okay? And it goes from C3 to C1260. And then you go done, okay? And it tells you that you get 44.09693. Or, if you look at the calculation that I did, my very own self, I got 44,00963. Exactly the same thing. So that's a way to verify that you're doing it right, so that when you do an example of how to actually do a mean calculation, you can use that sum, you can divide it by that n value, and you can get that particular value. Now, to go along with the mean, of course, we have standard deviations. So let me go all the way back up to the top. If you remember the formula for a raw standard deviation, you take your value, I have your x minus mean, you take your value and you subtract your mean. And then you get what's called a deviation. And then what you do is you square the deviations to get the standard deviation. And then what you do is you add up all the squares of those deviations, all right? Which we can use the function in order to do here. And then we divide by n minus 1. Why am I doing n minus 1? Again, for a standard deviation or a variance, this is a sample. I'm assuming that my stock has been around for longer than 5 years. Okay, so my 5 years is only a sample of all of the stock prices that are out there in the history of this stock. Okay? I've also got Z-score here, but I'm going to do that one later Okay, so again, I would do this like I was doing this by hand. Now I have to create my own formula for this. I also have to have my mean. Okay, so I go x, remember this is my x. Okay, so in this spot, I'm going to go x minus my mean. So up here I go equals. Okay, and then I say my x value, 45.62, minus my mean. Now, you could just type in the number 44.0963, whatever it is, but I want to be able to use the software properly, so I'm going to go ahead and click on this. And if I look at my formula way back up at the top, I'm going to see that it's going to be C3, this guy, minus my mean, which is all the way down there. Now, remember, I'm going to slide the formula and do this for every single one all the way down to the bottom. That being the case, then I want to make sure I use absolute cell referencing. So I put the dollar signs to keep it the same for my mean. I want the other values to slide. I want the C3 to become C4 and C5 and C6 as I go along. But if I use that absolute cell referencing, then it's going to give me that deviation. You can go ahead and calculate to make sure that's right. It was 44.09. This is 45.62. So if you subtract the two, I think it's about 1.52, 1.51 in there somewhere. Yes, so obviously that's right. Then all you do is, again, you want to replicate that formula. So you go from fat plus to skinny plus, and then you drag. Now, hopefully you have a good mouse. And as I said, you're going to have to do this for all these values. So you got to have a bit of patience. Hopefully you can see it scrolling all the way down to about 1260. And then when you get there, there you go. You go all the way down to that point. Boom. That's going to be all of the deviations for all of them. Some will be negative, some will be positive. As you travel up and down, some negatives and some positives. And those are going to be all of my x minus my mean, or my deviations. Then what I want to do is I want to square it. So again, I'm going to create my own formula, go equals, and then I'm going to say, okay, I want to take that thing, x minus my mean, and I want to square it. Remember, squaring it is hat 2, or to the power of 2. You press enter. 1.5 squared is about 2.25. So 1.52 is going to be a little bit more than that. You can try it out with your calculator to be sure. And then the same thing. Grab it, drag it when you're at skinny plus, all the way down till you get to 1260. Okay, there you have it there. Okay, now remember, in order to calculate my standard deviation, so if I was going to do this by hand, I've got my mean over here. I'm going to do my variance first because it's easier. Remember, my variance is I'm going to go all the way up to the top. My variance is the sum of x minus my mean squared, or the sum of my deviation squared, divided by n minus 1. Okay, or 1,257. So I'm going to do that same calculation. I'm going to zip all the way down to the bottom because I want to add them all up. And if you're going to show me how to do the calculation, you're going to need some sums. So if you remember here, the sum is right here. This was the sum of all my values, my x values, my stock prices, to get my mean. If I slide this over here, I get the sum of each of these columns. Now, the sum of this column is pretty much useless to me. But the sum of this column is exactly what the numerator of the variance is. Okay, remember, it's the x minus my mean, my deviation, squared, and then add it all up. Well, this, again, column is x minus my mean squared, and then right at the bottom, add it all up. I'm not very good with that. Okay, so I'm going to take that 7,001. So I create my own little formula, equals, and I take my summation, and I go slash for divided by, and then I go 1, 2, 5, 7, because it's 1,258 minus 1, and then you get your variance. Okay, now to get my standard deviation, there is a simple formula. Again, to make sure that I did that right, 5.57. Okay, I'm going to go over here where I have these calculations, and I'm going to do a variance calculation anyway, just to be sure that it's going okay. So I go to my FX. I go to my, oops, I don't think it remembers variance. So I go variance. Okay, I think it's just var, actually, is the abbreviation that works. And I want to do variation for a sample. Okay, a sample variation. Okay, I insert it. I again have to know what values I'm going to use. That, remember, I've still copied that C3 all the way to C1260, my 1,258 values. Okay, and then I go done. And what's the value that I get? 5.57. What's the value that I got when I did it by hand? 5.57. Beautiful. Okay. For my next one, for my standard deviation, I'm just going to abbreviate it SD. My standard variation, remember, is my variance squared. So I go equals variance square rooted, I should say, square rooted. Square root, if you remember back from your grade 11 days, is to the power of 0.5. Okay, 1/2 is the same thing as the square root. So I press enter, boop, and the square root of 5.57, okay, is 2.36. Okay, again, you can do the same sort of thing if you wanted to, if you don't trust yourself or whatever it may be. Okay, when you go to do the standard deviation, you put in your fx, okay, function. Here you go, standard deviation, STDEV, I think is the abbreviation for that. I want that for a sample. Okay, make sure you pick for a sample because the value will be slightly off. Insert the function. Again, you want to do it for your data sets from C3 to C1260. You press done. Boop, boop, boop. You get 2.36. And does that agree with my? Yep, 2.36. Okay. And so there you have it. Okay, you've got exactly how to do single variable stats and to use Microsoft Excel to do all that number crunching for you. Now, if you want to do a Z-score for any one of these, it's very easy to do. Again, an equal sign, you're going to take the value minus your mean. I got to get my mean all the way down here. Minus my mean, okay, divided by my standard deviation. Okay, so I'm going to go divided by, I'm going to have to put some brackets in afterwards. I'll edit that afterwards. My standard deviation, which is this number here. Okay, now, problem is I got to put brackets in there because we want the order of operations to do my subtraction first. You need to have it in brackets, so subtraction will be first. And then you've got yourself your beautiful formula for your, let me get this out of the way here, for your Z-score. Okay, 45.6, that's 1.58 divided by my standard deviation, which was about 2.3, 2.4, and you get positive 0.64. You usually keep 2 decimal places for that Z-score. If you wanted to replicate that formula, we would have to put in some absolute cell referencing for my mean and for my standard deviation. But if I did do that, I could zip my way all the way down there. It's not really a requirement for your CPT, but you could zip that all the way down there and have Z-scores for every single one of those. Okay, so there's some single variable stats. Hopefully you remember how to do all of those. I don't expect you to show me by hand how to do any of the other calculations, but I will expect a mean, a standard deviation, and a variance to be calculated by hand. What I am going to do is show you again how to do some grouped stats. Okay, as you can see a little bit above here, you can see my table for frequency, cumulative frequency, relative frequency. I don't know why I have 2 columns for that. And then I could also do some calculations for my 2 variable stats where I have a grouped mean and a grouped standard deviation. Okay, but again, those calculations aren't as necessary because I'm not expecting you to do any grouping calculations for your means and your standard deviations and things like that. I'm only expecting you to do, for grouped data, I'm only expecting to do what's called a probability distribution or a relative frequency distribution. So anyway, so we'll do another video and we'll get at that stuff as well. Okay, hopefully that helps. Okay, and you can utilize Microsoft Excel to its nth degree for what you need to do.